Greetings, Fire Chargers, Darkblade here, and in this video we will mathematically calculate the date of the Exodus. First question, what information do we have about the date of the Exodus? Well, we know that it was in the 15th day of the Hebrew lunar month of Nisan, because it was on the 14th day, just before the sunset, where the Jewish New Day begins, that they slaughtered the Passover lamb. By the way, I am one-handing my recording device, so they left shortly after on the 15th day. And specifically, that was the first full moon of spring, because that's when Passover, which is the commemoration of the Exodus, typically is. So let's find a new moon to count back lunar cycles to get back to the Exodus. Now, when was the Exodus? It was in 1263 BC per Egyptologist David Falk, and there are some pointers for that, like Ramses II's oldest son, Amenhotep, suddenly dying at that time. So let's count back to the first full moon of spring in 1263 BC. We need an anchor date that is also a full moon. So I picked July 21st, 2024, which is the date that my Ursul ring in Pokemon Go evolved into Ursaluna. In order to be able to do math with that date, we need to convert it into its Julian day number, which is essentially just a count of days since one point, like 6,700 years ago. This is the formula for converting a day into a Julian day number. You take the month minus 3, divide that by 12, and that resulting integer is the C0, which will always be 0 or -1 in this case. The year number plus the C0 is x3. Divide x4, and it's the x4. Divide x4 by 100. The quotient is x3 and the remainder is x2. x1 is the month number minus x3 minus 12C0. And the total JDN, the Julian day number, is 146,097x3 divided by 4 plus 36,525x2 divided by 100 plus 153x1 plus 2 divided by 5 plus the day number, that's the day of the month, plus 1,721,119. This is from Astronomy Answers. There's also ways to convert a JDN to a Gregorian date number. So multiply the JDN by 4 and then subtract 6,884,477. This would result in a quantity. You want to divide that quantity by 146,097. x3 is the quotient and r3 is the remainder. Now take r3 divided by 4, multiply that quotient by 100, and then add 99 to the product. This will give you a sum. Divide that sum by 36,525. x2 is the quotient, r2 is the remainder. Now let's take r2 divided by 100, multiply the quotient by 5, and add 2. Divide the sum by 153. x1 is the quotient, r1 is the remainder. The day number, that's the day of month, is r1 divided by 5, and then plus 1. The C0 is x1 plus 2 divided by 12. The year number is 100x3 plus x2 plus the C0. And the month number is x1 minus 12C0 plus 3. Also, ways to convert a JDN to a date in the Julian calendar. You take this number, which is called a Y2, by taking the JDN minus 1,721,118. K2 is 4 of the Y2 plus 3. The K1 is the K2 mod 1461, so that you divide K2 by 1461 and take the remainder. That is divided by 4, the quotient you then multiply by 5 and then add 2. That's K1. X1 is K1 divided by 153. By the way, whenever I say divided by, the results are always integers, rounded down. And C0 is X1 plus 2 divided by 12. The year number is K2 divided by, it appears to be 1,461 plus 3. The month number is X1 minus 12C0 plus 3. And the day number is K1 mod 153 divided by 5 and then plus 1. So what is the Julian day number for July 21st, 2024? The answer is 2,460,513. Now, in order to get back to another full moon, we should subtract a whole number of lunar cycles. And since the Exodus was a very long time ago, we should subtract a lot of lunar cycles. So how many should we subtract? For now, I'll go with 40,600. How long is the lunar cycle? It's 29.53059 days. So multiply that by 40,600 and we get 29530 point. No. So we multiply this by 100, divided that by 100, so we get 2953059 times 406. So 59 times 6 is 354. And what is that's 6 times 3 is 18. Move over this 1, 3, 57. Okay, Google. 2,953.059 times 6.
2,953.059 times 6 is 17,718.354.
Now we multiply this by 400, which is the same as 295,305.9 times 4. So what is 59 times 4 is 236. 236. And 4 times 3 is 12. 1, 2, 36, 8, 3. So we end up with 954. Okay, Google. 2,953.059 times 406.
2,953.059 times 406 is 1,198,941.95.
So we're going to roll down that to the whole, so that would be 1,198,941.95. 0.942. Because 0.46 days is equal to 0.046 days is equal to about 0. No. Okay, Google. 0.046 days to hours.
0.046 days is equivalent to 1.104 hours.
A little over an hour, so it doesn't matter. Okay, Google. Cancel. I have no idea if I just asked Google anything. So 1198941. Okay, Google. 29.53059 times 40,600.
Sorry, I didn't understand.
Okay, Google. 40,600 times 29.53059.
40,600 times 29.53 is 1,198,918.
Okay, Google. 29,530.59 times 40.6.
29,530.59 times 40.6 is 1,198,941.95.
1,198,900. So we're going to use whole numbers. So that would be 1. And because pretty much all of the digits, because the majority of the digits in the subtrahend are smaller than their equivalent place digits in the subtractor, we're going to need to use a lot of borrowing. So this becomes 3, and this is 16 or 15. This becomes 9. This becomes 14, and this becomes 11. So that would be 2, 6, 1, 5. Okay, Google. 2,460,513 minus 1,198,942.
2,460,513
What?
minus
Okay, Google.
198,942.
Okay, Google. 2,460,513 minus 1,198,942.
2,460,513 minus 1,198,942 is 1,261,571.
1,261,571. So this new JDN we're working with is 1,261,571. Now let's multiply this by 4 because we have to. That would be times 4. That would be 15 times 4 is 60. 628. And that would be okay, Google. 1,261,571 times 4.
1,261,571 times 4 is 5,046,284.
Now subtract that by 688,504. Okay, Google. 6,884,477 minus 5,046,284.
6,884,477 minus 5,046,284 is 1,838,193.0000001191.
That was just weird. It got those zeros out of nowhere. And I said million, not billion. So let's divide 1838193 divided by 146,097. The answer is 1,460. And math is, this should be 72. 37. Now, technically this would be 12, but since we're working with the BC numbers, we are going to say that this is 13. And this would be, so mine, because in the BC, the century number comes at the beginning and you count upwards. Forwards gets you a smaller number. So that would be x3 equals minus 1. Oh, by the way, I accidentally put the x3 as superscript instead of subscript. So now it looks like what is it called? An exponent. So let me 1,460,97 times 3 equals 272. 420, 18, 4. Okay, Google. 146,097 times 3.
146,097 times 3 is 438,291.
So we'll subtract 3. Is that right? 3. No, it's 3, 7. 7, 2, 2, 3. So 91 minus 23 is 68. And 0, 1. Oh, what is it called? R3 appears to be 61,068. Okay, Google. 438,291 minus 377,223.
438,291 minus 377,223 is 61,068.
So what is it called? R3 is 68. And now we need to divide this R3 by 4. So 61068 by 4 equals 1. 2. Okay, Google. 61,068 divided by 4.
61,068 divided by 4 is 15,267.
So we take that. So 152 and divide it by 36,525. One, 4, 6. Five, 7, 9. Okay, Google, repeat that.
61,068 divided by 4 is 15,267.
Okay, Google, 146,097 times 13.
146,097 times 13 is 1,899,261.
Okay, Google, 1,899,261 minus 1,838,193.
1,899,261 minus 1,838,193 is 999.
Okay, Google, 146,097 times 13 minus 1,838,193.
146,097 times 13 minus 1,838,193.
Okay, Google. Okay, Google. Okay, Google. Stop that. Okay, Google. 146,097 times 13 minus 1,838,193.
146,097 times 13 minus 1,838,193 is 61,068.
So 61,068 should be right. Okay, Google. 61,068 divided by 4.
61,068 divided by 4 is 15,267.
Okay, Google. 1526799 divided by 36,525.
1,526,799 divided by 36,525 is approximately 41.8.
So, yeah, our x2 should be that 36,525, 7, 4. Okay, Google. What is 65,799 minus 36,525?
65,799 minus 36,525 is 29,274.
So now we need to find what x1 and r1 are. So we take r2 divided by 100. So that's... Okay, Google, repeat that.
65,799 minus 36,525 is 29,274.
So 292 times 4 is... That's 500. Wait, 29. 29 is 1 less than 30. Oh, great. 8, 6. So get 1168 plus 2. So 1170. And let's just multiply by 7 for no real reason. No, 7, 105. No, that's 35. Then we get 107. Okay, Google. 292 times 4.
292 times 4 is 1,168.
Okay, Google. 1,170 divided by 153.
1,170 divided by 153 is approximately 7.65.
Okay, Google. 7 times 153.
7 times 153 is 1,071.
Okay, Google. 1,170 minus 1,071.
1,170 minus 1,071 is 99.
So 99. Okay, Google. Repeat that.
1,170 minus 1,071 is 99.
So R1 equals 99. And 99 divided by 5. So D equals 20. And the C0 equals, what is 0, because 7 plus 2 is 9 divided by 12 is 0. And the J equals minus 1,300 plus, what is the x2 number? X2 is 41, and plus the C0, which is 0, that would be minus 1, 2. It's about 1260 BC, which is a bit late. And the month equals 7 minus 4, 3 equals 4. So now we are at April 20th, 1260 BC. So this is 1260, which is still a bit too late. So we need to subtract an even greater amount of what is it called? Lunar cycles. Let's go with 29.5305 times 44. That should equal to, let me see, that should be 236 1812. I'm going to say no to that because it is not enough to get a whole number. So what about 45? 29.53059. 45. That would give us 250 plus a bit shy of 300. And 5, 1, 6, 2. And that is 7, 4. And that is 29 and 0, 1, 8, 1, 2. Wait, something seems fishy. There should be 8 times more than this. Okay, Google. 29.53059 times 400.
Sorry, I didn't understand.
I don't understand what's going on. Well, if at first you don't understand, just hand do the math. So this is 6, 3, 3, 1, 1, 2. That should be about 5, 6.872. Okay, Google. 29.53059 times 45.
Sorry, I didn't understand.
Okay, Google. 45 times 23 point cancel. Okay, Google. 45 times 29.53059.
45 times 29.53 is 1,328.85.
29.53059 times 45.
29.5305 times 45 is approximately 1,328.8765.
So we'll subtract R from our target JDN, which is 1261571 minus 132, which should only be like not even 4 years. 71 minus 30 equals 41. 0, 2, 1, 2, 2, 6, 0. Let's multiply this by 4. That is 5040968. 1,260,242 times 4.
1,260,242 260,242 times 4 is 5,040,968.
Okay, now 6884477 minus 5040968 0935, and that's 184. Anyway, I'll call part 1 here because this video is already 36 minutes long. So that's all for today's video. Make sure to like and subscribe, and I'll see you at part 2, where I finish calculating the date of the Exodus. Goodbye, Fire Chargers. Dark Blade out.